Welcome to Ask and Learn.
This is the answer to Chapter 20, problem number 53 from the Smith Organic Chemistry textbook. And this problem asks us to identify the lettered compounds in the following reaction scheme. Then we're also told that compounds F, G, and K are isomers of molecular formula C13H18O. And we're asked, how could proton NMR spectroscopy distinguish these three compounds from each other? Okay, so I am just going to run through and do the products first, and then we can talk about the second part of this question. Going from the starting material here, I'll go to the right first. So A is going to be the addition of phenylmagnesium bromide. So this is a Grignard reagent. So this is a Grignard reaction in which we add a phenyl ring. So we'll get an alcohol from our ketone, and we'll add a phenyl ring. So I'll just put pH. Okay. So that's going to be A. So there's A. So then from A to B, we're going to treat A with concentrated sulfuric acid. So that's going to eliminate our alcohol. So molecule B is going to look like this. So I'll draw the phenyl ring in this time. So here's our phenyl ring that we added in A. And then in B, we have a new double bond in the cyclohexane. So that's B. Okay, so moving down now. So I'll do starting material to H. So to get to H, we're using lithium aluminum hydride followed by water. So that's just going to be a reduction. So we'll have our cyclohexane ring with an alcohol where we had the ketone in the starting material. Okay, so then we treat that. Oh, and I should say this is H. So then H to I is PBr3. And so that is going to replace our alcohol with bromine. So this is I. I to J, we're just using magnesium. So we're going to make a Grignard reagent out of I. So now we have the magnesium bromide. Okay. So, that's J. Keep forgetting to put the letters in. And then J to K, we are using our newly formed Grignard reagent, J, and treating it with benzaldehyde, which is going to do a Grignard, and then working it up with water. And so our product is going to be this. With an alcohol here. Okay, and so this is K. All right. So then on the next page, we start from B. So I've redrawn B here, and we do several different things to B. So let me go ahead and label this as B. Okay, so first to get from B to C, we're using ozone and then dimethyl sulfide. So that's going to cleave the double bond that we formed in B. And so we will end up with this molecule. So remember, ozone's not going to cleave the double bonds in an aromatic ring, so they're still all intact. And where our double bond was in B, we will now have two carbonyls. So a ketone and this aldehyde. Okay, so that's going to be molecule C. When we treat B with hydrochloric acid, we're going to do a hydrohalogenation. And so, I don't want to run out of room here. So let me move let me move this, put this over here, sort of out of the way, and then draw this arrow like this so that we can see that it's continuing over there. So that's C. So then for D, as I said, we're going to do a hydrohalogenation. So our aromatic ring, again, will be unaffected by this. And our double bond will be replaced with a chlorine and a hydrogen. And by Markovnikov's rule, the chlorine will add here. And so this is molecule D. And then to get from D to F, we're going to use magnesium. So that's going to make our Grignard. And then we're going to react that with formaldehyde and then work it up with water. And so our final product here, E, is going to look like this. So we've essentially just added a carbon here, and then we have an alcohol on that carbon. So there we go. That's F. Okay, to get from B to E, we're using MCPBA, which is going to make the epoxide. So here's that epoxide. It's going to look like this. Okay, and so this will be E. And then to get from E to G, we're using the methyl organocuprate followed by water workup. And so that's going to just act as a nucleophile and open our epoxide. And so it's going to attack at the less substituted carbon. So our alcohol will be here, and we'll have a methyl group there. And so that is going to be molecule G. Okay, and that's the first part of this problem. So then here on the third page, I'm going to address, oops, I forgot, this should be K. All right, I'm going to address how we would distinguish F, G, and K by proton NMR. And so their NMRs are all going to be pretty similar, but there are going to be differences that we can pick up due to the presence of the alcohol. So F, in F, there are two protons here and here on this carbon that also has the alcohol on it. And they have no neighboring protons. So that they're going to show as a singlet in the 3 to 4 ppm range. So we're looking for a singlet around 3 to 4 ppms there. G is a tertiary alcohol. So tertiary alcohol in G. So we're not going to expect to see any signal between 3 and 4 ppm. So no 3 to 4 ppm signal. And so that would be how we would distinguish G. And then in K, K is a secondary alcohol. So there's one proton here, and there's a neighboring proton here. And so what we would expect for K is that it's going to show as a doublet. The red proton should show as a doublet. And again, that's going to be between 3 to 4 ppms. So basically, we're not going to see any signal for G. For F, we should see a singlet in the 3 to 4 ppm range. And for K, we should see a doublet in the 3 to 4 ppm range. And so that's how we could distinguish the three of them by proton NMR. And again, here are the structure answers for the lettered compounds in green. And that's the answer to chapter 20, problem number 53.